Hello students, this is in continuation with the previous lecture in which I have explained about instantaneous reactive power theory. Today I will discuss example 5.2 of my NPTEL book that I have sent you by attachment, or you can refer by NPTEL course. Some misconceptions in reactive power theory or instantaneous reactive power theory or simply PQ theory. Okay. Now to explain this, I shall use the results obtained in the previous lecture. If you remember that last time when I have explained this, we have found relationship between the alpha beta components and its active and reactive components in ABC coordinate. Okay, if you look at here, these are the ABC coordinates. Okay, so these relationship actually explains the connection between the active reactive components in alpha beta to active and reactive components in A and B through these matrices. So we shall use these results directly in our current discussion. Okay, so coming to today's discussion, we have this kind of a arrangement where we have used the three-phase, three-wire system, and the primary side we have the delta connected binding, and secondary side we have the star connected binding. Okay, we have to find the active and reactive components of current on the primary side and try to understand the phenomena of instantaneous reactive power theory and its application to understand the active and reactive components of the currents. Okay, so first thing, how to find out, basically we are trying to find out what is IAP, what is IAQ, what is IBP, what is IBQ, what is ICP, and what is ICQ. Okay, that we will try to understand today. Now look here, we have to solve first the circuit and then we have to find out the currents. Now since it is three-phase transformer, so voltage will transform from primary to secondary, so therefore the primary voltage are given to us basically BA and BB and BC. Okay, and these are root 2, you can say V sine omega t. This is root 2 B sine omega t minus 120 degree, and this is root 2 B sine omega t plus 120 degree. Okay, so these are the timings. These are the basically expressions for the voltage. Now these voltage will go to secondary side. Okay, here these will go to secondary side, this side. So obviously BA, BB, BC, we have used small subscript notations, small letter subscript notations for the secondary side and capital letter for the primary side. Okay. Now from this you can find out line to line voltages, because if you see that this binding and this binding will have a 1:1 transform voltage. Okay, but this winding actually has a voltage of line to line, because this is line to line connected primary winding. So you can see it here from this to this. So this point is actually B point, this point is A point. Am I correct? This is B point, this is A point, and hence the AV appears across this winding. Therefore we need to find out what are the A to B voltages, line to line voltages. If you recall from our previous discussions, you can find out directly. Okay, in phasor form, B phase is down, take it up, and join A and B will get 30-degree lead. So we'll get root 3 root 2B sine omega t plus 30 degree. Similarly, you will get BVC as root 3 root 2B sine omega t minus 90 degree. Shift of minus 120 degree, and VCA equal to root 3 root 2 B of sine omega t plus 120 of this, okay, or plus 120 of this, so plus 150 degree. These are line to line voltages, and these will appear as the phase voltages on the secondary side. So obviously you can see that this is nothing but actually BA. This is BB. This is BC. So these are actually secondary winding voltages. Am I correct? Secondary winding voltages. Now once we know the secondary winding voltages, we can find out the secondary currents. Okay, secondary currents can be found out simply by taking care of load. So let us take the load is resistive load between A and N. Therefore current IA is nothing but VA by R, which is nothing but BAB by R. Okay, that means nothing but root 3 root 2 B by B into sine omega t plus 30 degree by R. R is given as a 4 ohm, but let us say this is R only. So this can be written as root 2 into root 3B by R into sine omega t plus 30 degree. Now this whole thing can be referred as the IRMS. Okay, this is IRMS. So we can write this as root 2 into I sine omega t plus 30 degree. This is IA. Okay, this is IA. But about IB and IC? IB and IC will be equal to 0, because there is no load between phase B and phase C, and therefore the current between through the phase B and C will be 0. Okay, so I can write here IB is equal to 0 and IC is equal to 0. Okay, so these are actually three-phase currents on the secondary side. Now these currents on the secondary side get transformed to primary side by transformer action. So current which is here, okay, this current is basically IA current. This will get transformed to this current. Okay, see the arrow here? This current will now get transformed to this current. Therefore, what is capital IA? Capital IA is therefore IA, because turn ratio is 1:1, which is same as root 2 into I sine omega t plus 30 degree. Okay, now this current basically go like this. The path is shown by these lines here. Okay, maybe I can use a thick pen, and comes here and comes here and goes like this. So this is the path. Therefore this current is 0. This current is 0. Okay, and in this point current flows but the reverse of IA. So from this you can write IB is equal to minus IA equal to minus IA equal to minus root 2I sine omega t plus 30 degree. Okay, and obviously IC is equal to 0. If we consider an ideal transformer, the current would like to flow through the least impedance path. It will not be divided between these currents and these currents. Okay, so we have taken an ideal transformer. So this is the primary side current. Okay, these are the primary side currents. So we know the primary side voltage, we know the primary side current, we can find out the alpha beta components, and then we can resolve them into active and reactive components of the currents on the A, B in form of A and B and C phases. Fine. So now let us proceed it. So we know IA, IB, IC. So let us now find out what is I alpha and what is I beta. I0 is 0 anyway because this is three-phase, three-wire system. Correct? We will find out first B alpha and B beta. Primary side. This matrix is here. If you remember last time, this is BA primary side and BB. Okay, do you remember this matrix? This was 3 by 2 root 0, and this is 1 by root 2 and root 2. And BA, you remember, nothing but root 2 into B into sine omega t, the first one, and then we have root 2 into B into sine omega t minus 120 degree. Okay, so this is root 2 B sine omega t minus 120 degree. These are the alpha beta components. Okay, we will solve this and find out. The first one is simple because this is nothing but the product of root 3 by 2 into root 2 become root 3 B sine omega t. The second one is root 2 into this plus root 2 into this. Okay, so we need to sort it out. I will do this side some calculation. Okay, the calculation is this, that 1 by root 2 into root 2 sine omega t plus root 2 into root 2 becomes 2b. B is common, of course, so b is common, sine omega t plus minus 120 degree. This is minus 120 degree. Simplify this, you will get, this is b by 2, so b is common. So this is sine omega t by 2. And this is twice of sine omega t minus 120 degree. Am I correct? Root 2 I have taken common. B is common, so root 2 by root 2 becomes 1. Okay, so this is 1 actually, this is not 2. Sine omega t, and this is by root 2 because this is actually root 2. This is root 2. So I have taken common actually b. So root 2 will not come here. This can be removed here. It is simply b. Okay, this is simply b. And this also will not come. So sine omega t plus 2b sine omega t minus 120 degree. Okay, if you simplify this, then it becomes nothing but you can expand this, or you can use phasors for this, whatever way. If you use phasor for this, then I can sum these two signs like this. It becomes 1 angle of 0. This becomes 2 angle of minus 120 degree. And which is nothing but 1 plus twice of sine cos 120 minus same as cos 120, the cos 90 plus 30, and it becomes minus sine 30. So this becomes minus half. Okay, cos 120 is cos 90 plus 30, so minus sine 30 means minus half. This into 2, then plus j into 2 into sine of minus 120 is minus sine 120, so minus will come here, and sine 120 is sine 90 plus 30 cos 30, so minus root 3 by 2. Correct? So this becomes actually 2 is gone with this, so this becomes 0, is it? So and this is gone with this, so this is 0 here, and this is minus j. 2 is gone with this 2, and this is root 3, so it becomes root 3 minus root 3 angle of 90 degree, or root 3 angle of minus 90 degree, whatever you find it suitable. Again convert back into sine, it becomes root 3 of sine of omega t, okay, or plus 90 degree. If I take the first one into time domain. So this expression becomes nothing but minus root 3 cos of omega t. So therefore, if you simplify this term, it becomes minus root 3 b. So minus root 3 b cos omega t. Fine. So this is the B alpha and B beta equal to B alpha and B beta. Remember this, it's very important expression. We will use this in our further calculation. Okay. Now come to I alpha and I beta. So I alpha and I beta will be similar to that. The matrix is same, and that is root 3y2 0. This is 1y root 2. This is root 2, and this is IA and IB, which already we have found out. What is IA? We have found out IA as, if you look upside, this is root 2 I sin omega t plus 30, and then minus root 2 I sin omega t plus 30. So this becomes root 2 I sin omega t plus 30 degree. This is minus root 2 I sin omega t plus 30 degree. Okay. Simplify this further, then we'll find the first becomes simply root 3 I sin omega t plus 30 degree, and second becomes root 2 into root 1 by root 2 into root 2 becomes 1. So this is I minus 2i, so become minus I sin omega t plus 30 degree. These are I alpha and I beta. Correct? So now we know for this case what is I alpha, what is I beta, what is B alpha and what is B beta. Now we can find out the powers. Okay, so we can find out the powers using these expressions. So obviously the power Pt is nothing but V alpha into I alpha plus B beta into I beta. That's fine. Now you know what is B alpha. The V alpha is nothing but root 3 into B into sin omega t. What is I alpha? Just we find out root 3 into I into sin omega t plus 30 degree. So this is root 3 into I into sin omega t plus 30 degree. This is the first part, and second part is beta b is minus root 3 b cos omega t. We just have found out what is b beta into minus I sin omega t plus 30 degree. Okay, so this becomes nothing but 3bi, this is bi, okay, sin omega t. This term is common in both, so I will take this thing as a common, so it becomes bi sin omega t plus 30 degree is common here. What is remaining therefore? Root 3 is here, sin omega t, correct? Here it is plus, what is remaining here? Root 3 I can take common outside because root 3 is common both the sides, or so we can take root 3 outside. Okay, therefore only the root 3 is here. This makes 3 and 3, and this side only Root 3 is there, therefore cos omega t. This is here cos omega t. Close the bracket here. Now we will see what is this. Okay, so we will divide by 2 here and divide by 2 here. Now what is this? This is nothing but sine omega t plus 30. This is sine omega t plus 30 degree. The whole thing. And here it is, since we are divided by 2, to multiply by 2 also. Okay, so we have to multiply by 2 as well. Therefore here you will get this term equal to 2 into this. Okay, so that means that we have now root 3 bi into 2 sine omega t plus 30 degree into this, which means it's a square of, basically it is the 2 sine square omega t plus 30. Okay, so I can remove this, it becomes root 3 bi into sine 2 sine square omega t plus 30 degree, which gives the expression of root 3 bi 1 minus cos 2 omega t plus 30 degree. So we have transformed the square term into cos 2 omega term. This is p function of time. Remember, very important expression, this one we will use it further. So this I will mark it here. Now let us find out the reactive power. Okay, so Qt, as you know, the Qt is nothing but basically Q alpha beta. So this is B alpha into I beta minus B beta into I alpha. You know this? So what is B alpha? Just we find out, nothing but root 3 into B into sine omega t. What is I beta? Minus I sine omega t plus 30 degree. This is the Q. And then you have a minus sign. Beta b is minus root 3 b cos omega t. This into I alpha is root 3 I sine omega t plus 30 degree. Okay, we simplify this, we will get this term as, what is common this time? This thing is common, and these two terms are common, so this is common and this is common. So take this as a common, we will get here root 3 bi sine omega t plus 30 degree, and in big bracket we will get first term as minus sign is here, so minus sine omega t, minus minus become plus here, so plus root 3 cos omega t. We can take minus outside. Okay, in that case it becomes minus here and plus here. So this becomes or we could ask such, it's not a problem. Okay, so this becomes, both have a minus term. I think this is minus b beta, so minus minus plus. I alpha is root 3 and I b alpha b alpha is positive and I beta is minus I sin omega t. So if I take this common and take 2 common once more, it becomes root 3 bi minus, take 2 down here, 2 say multiply, then 2 divide. So this becomes 2 sine omega t plus 30 degree here, and this becomes sine omega t, so 1 by 2 sine omega t, and this is minus root 3 by 2 cos omega t. Okay, now this becomes, the whole expression becomes cos omega t plus 30 degree, correct? So this into, this is here 2 sine omega t plus 30 degree, this is 2 sine a cos b, 2 sine a cos a, so this become nothing but minus is here, I, and therefore this is minus of cos, so remember this is minus of cos of this, so you can take this bracket here, so minus is minus here, minus become plus, so this is root 3 bi sine 2 omega t plus 30 degree. This is qt. So we know pt and we know qt. Now we can find out the other terms. Based on these powers, using the reactive power theory, we will resolve these powers in terms of the current. And then we'll find the alpha beta components of the current, and then their active and reactive parts, and then finally their active and reactive parts in the ABC frame of reference. Okay, so now we know P and Q, we directly find out what is the alpha beta. So we already know that I alpha and I beta, by this expression I alpha and I beta by alpha beta transformations is nothing but I alpha P, last time we proved it, I alpha Q, this is I alpha Q, I beta P and I beta Q. Okay, this is I beta P plus I beta Q, and this we can write in form like this: I alpha P, I beta P plus I alpha Q and I beta Q. And last time we proved what is I alpha P, what is I beta P, what is I alpha Q, what is I beta Q. Remember? Should I recall, or should I go back, or you will try to see that? Do it. So if you remember, I alpha P was nothing but B alpha Y B alpha square B beta square into B. And if you remember, this is root 3 into B into sine omega t. This is root 3 sine omega t whole square plus minus root 3b cos omega t whole square. And P, if you remember, the P was 3bi 1 minus cos 2 omega t plus 30 degree. So this was root 3 into b into I into 1 minus cos. Okay, so this term was here 1 minus cos 2 omega t plus 30 degree. This was the P. Now this is like sine square theta plus cos square theta. So this goes as 3b squared. This will go with root 3b and root 3b. So finally we have only current component, that is simply I sin omega t. So this becomes I sin omega t and 1 minus cos 2 omega t plus 60 degree. If you want, you can multiply 2 inside. This is the current I alpha P. Then what about I beta P? I alpha Q or I beta P, you can find out whatever you like. Okay, so we can find out I beta P. So I beta P was B beta Y B alpha square B beta square into P. So here it becomes simply minus root 3 cos omega t. So there will come minus sign will come here. So finally it becomes simply minus I cos omega t 1 minus cos 2 omega t plus 60 degree. This is I beta P. Similarly, I alpha Q. I alpha Q is minus B beta by B alpha square B beta square into Q. Okay. So you know what is beta B, B beta. So this is minus root 3 into B cos omega t, and this becomes 3b squared because this is the square term. Okay, Q already you know, root 3 into b into I sine 2 omega t plus 60 degree. So this 3b will go with this and this. Finally minus minus become plus, and this becomes I cos omega t into sine 2 omega t plus 60 degree. This is I alpha Q. Okay, this is I alpha Q. This is I alpha P. This is I beta P. And what is I beta Q? I beta Q will be I I beta cube will be B alpha y B alpha plus B beta square into Q, which means this is root 3 B sine omega t by 3b square root 3bi sine 2 omega t plus 60 degree. So this go away with this. Finally we have I sine omega t into sine 2 omega t plus 60 degree. Okay, this is I beta Q. I will have different colors for this currents. So maybe I can remove this and use this color for a highlight. Okay, so maybe this will be more better for this and this. So what we know, I alpha p, I beta p, I alpha q, I beta q. Now it is time to find out back what are IAP, what are IAP, IBP, and so on. IAQ, IBQ. So earlier we have established the relationship between these components. For example, if you remember, I alpha p, I beta p. This matrix has to be multiplied by to find out I AP and I BP. This we have done in the beginning. Okay, do you remember this matrix? The conversion from alpha to A by inverse of the matrix which was given in the beginning here. Let us say this matrix. Okay, this matrix. So you have to take the inverse of this matrix. Alright, so inverse of this matrix will give you the value of alpha in terms of the A and B. So inverse of this matrix is this, nothing but 2 by 3 square root, this is 0, this is minus 1 by root 6, and this is 1 by root 2. You verify yourself. Don't trust me. Unless you verify, don't use directly. Okay. So I have to substitute these values to find out AP. Okay. Now from this, and similarly we can find out IAQ and IBQ same way, except that we now have I alpha q and I beta q here. So we have minus 1 by root 6, 1 by root 2, this matrix into I alpha q, this is I beta q. Okay, it won't take much time to do that, just substitute. Alright, so we will do it now here. Therefore, IAP is nothing but root 2 by 3 into I alpha p. And you know what is I alpha p? This is I alpha p is this. So this becomes 2 by 3 root, this is I sin omega t, and 1 minus cos 2 omega t plus 60 degree. Okay, we need to simplify this and see what it comes. We can expand these these two terms, so it becomes 2 by 3 square root I inside becomes sine omega t and becomes minus sine omega t plus into, okay, into cos 2 omega t plus 60 degree. I want to expand this, simplify in form of 2 sine a cos b. So multiply by 2, multiply by 2 and divide by 2. Divide by 2, it becomes iy root 6. This side here, okay, and here it becomes 2 sine omega t, kind of a 2 sine a cos b, okay. So it becomes 2 sine a cos b becomes sine a plus b plus sine a minus b. So sine a plus b becomes sine 3 omega t plus 60 degree, and plus sine a minus b becomes sine minus 2 omega t here, and minus omega t, not omega t, because omega t minus 2 omega t becomes minus omega t. So it will become minus omega t. Okay. So this is minus omega t and then minus 60 degree. So minus 1 has become plus, so finally it is actually iy root 6 2 sine omega t and plus sine omega t plus 60 degree here, and it become minus sine 3 omega t plus 60 degree. Okay. These two can be further combined because they are similar frequency term, either using phases or by expansion of these two. And finally, this becomes iy root 6 sine omega t plus 30 degree, and the magnitude is actually root 3 sine. These two become a one term, and this remains minus sine 3 omega t plus 60 degree. This is IAP. Okay, note this. IAP is what do you see it here? That it has two terms. The one is the fundamental term. This is the fundamental frequency term, and this is the third harmonic frequency term. Now, this is a conceptual question that why the third harmonic component is part of the active current in phase A. Because there is no harmonic load, we have only resistive load. So why that the third frequency term has come here. Okay. Similarly, we can find out the IBP, which is nothing but minus 1 by root 6 into I alpha p, and then plus 1 by root 2 into I beta p. Substitute in a similar fashion, simplify in the same style, you will get that IBP equal to minus I by root 6 in bracket root 3 sine omega t plus 60 this time, and this next term is minus sine 3 omega t plus 120 degree. Okay, I am leaving to you to prove. It's not very difficult, the steps are similar. Okay, and similarly I AQ, I will change the color to make it more striking to understand, to remember. IAQ, what is IAQ? Root 2 by 3 into I alpha q. Okay, simplify that, you will get I by root 6, verify with me, in bracket sine omega t plus 60 degree sine omega t plus 60 degree and plus sine 3 omega t plus 60 degree. Okay, and similarly we will have I BQ. Okay, IBQ. IBQ is I by root 6 will be minus 1 by root 6 into I alpha q plus 1 by root 2 into I beta q. Solve as we have done for the first one. We will get minus sine omega t. So minus sine omega t and minus cos sine cos 3 omega t plus 30 degree. Okay, or we can say, you can also write in form of sine as well. Three omega t plus 30 degree. These are the four expressions giving the values of active and reactive components of the current in ABC frame. Okay, and each of these terms have fundamental and third harmonic. So first question comes, from where these third harmonic component have come into picture, because we don't have any the load compensation of nonlinear load, we don't have any harmonic load. Okay, so therefore why it has come this term? And also note that we don't have any inductive or capacitive load. So at first place, why there is a reactive values of the currents. There should not be any reactive element, but we have reactive component of current. At the same time, we do not see that IAQ plus IBQ equal to 0. That means there is a net flow of reactive component even from the phase A and phase B. So this is a kind of a misconception that leads to a wrong interpretation of the active and reactive components of the current. Okay, and this is the answer of the question that find out the reactive and active components of the current in the ABC frame. So these are the equations for that. Very interesting part is that Akagi theory, or you can say PQ theory, or the theory of instantaneous reactive power compensation, says that the P is equal to, if you remember, root 3 into B into I into 1 minus cos 2 omega t plus 30 degree. This is for P, and Q is root 3 B into I sine 2 omega t plus 30 degree. Why? We will see. The question is that the theory says that you can instantaneously define the nature of powers, the active powers and reactive powers. Now, based on these instantaneous power expressions, can we tell about the nature of the load, whether it is resistive or it is capacitive or it is inductive? Let us see. If you observe these equations, then we see at omega t plus 30 equal to, let us say, 90 degree. This angle I will call as a theta. So theta is equal to 90 degree. So for this, what is P? P is, this is 90, this is 180, minus plus 1, so 2. So basically it becomes root 3 into 2 bi, okay, or 2 root 3 bi. What is Q? Q is sine 180 is 0, basically 0. And this indicates that kind of resistive load. My correct? Because reactive power is 0. Now we take another instant when omega t equal to, let us say, 105 degree, which means 2 omega t plus 30 degree is 210 degree, which means 180 plus 30. So what is cos 180 plus 30? Is minus cos 30, and minus cos 30 is root 3 by 2. So 1 plus root 3 by 2. So P becomes root 3 bi into 1 plus root 3 by 2. And what is Q for this case? Q becomes root 3 bi sine 180 plus 30 becomes minus sine 30, so minus half. So it becomes minus root 3bi into half, okay, 1 by 2. So you see the reactive power is negative. It's kind of a, you can say, capacitive load. And similarly, take the third case where we say that omega t plus 30 degree equal to, let us say, 75 degree. So 2 omega t plus 30 becomes how much? 150 degree, which is 90 plus 60. The P becomes cos 90 plus 60. Okay, cos 90 plus 60 is nothing but minus sine 60. So minus minus plus root 3 by 2. So this becomes root 3 bi 1 plus again root 3 by 2 and this is q is equal to sine 90 plus 60 becomes cos 60 1 by 2. This becomes root 3 bi 1 by 2. This time indicates inductive load because q is positive for inductive. So you see, at different instants we have a different characteristic. At this instant for omega t we have a resistive load. At this value of omega t we have a capacitive load. At this value of omega t we have a inductive load. Same configuration, but at different moment it describes a different kind of load, which basically means that it is misleading. I know that my load is resistive and hence there is no possibility of having capacitive and inductive load. Therefore, we conclude that the resolution of current components in terms of active and reactive components using the instantaneous reactive power theory components is misleading, and we have to be very careful when we study these active and reactive components using reactive theory. Okay. However, we can also conclude that it is not possible to define the property of the load or power phenomena by observing the instantaneous quantities. Okay, by observing the instantaneous quantities. Rather, we will observe these quantities over a period of one cycle, and then we can say that what are the average value of these powers. Then we can say whether the load is resistive, capacitive, or inductive. So we need at least one cycle time to observe the P and Q components, and then we can identify the nature of the load. Alright, so I will continue this in the next class also. The example 5.3 is similar to this, except that the load is replaced by the inductive load. Okay, and the similar kind of conclusions are being drawn, that it is a inductive loads are there, but still there are active components. So I hope you can go through yourself. Maybe in the next lecture I will just have a overview of that, and then I'll go the next topic, which is very important, and that is basically called the symmetrical component theory for the load compensation. So I will stop here, and The next lecture will be delivered maybe after a couple of days. Thank you.